In today's video, I'm going to be covering the ordering and manufacturing process for PCBs through JLCPCB. I'll show the importance of having sampling books and how you could use them for testing and troubleshooting your different circuit designs, along with the Digikey process that is involved with the different filters to select the best possible components. And finally, I'll be ending off the video with the JLCPCB process with the Gerber and CPL files. For this demonstration, I'm going to be using a buck converter that I designed 2 years ago. We're first going to start with the component properties, as it's very important to include all of the necessary information that you need so that if you ever want to refer back to this project, you'll have the part information, data sheets, and links that refer to each part. We're going to start with the resistors with RV1 and R2. We'll start with R2 first. If I hit the E button, under the symbol properties menu, we're going to be filling out the part number, price, and Digikey link for each of our components, along with selecting a footprint. So I know in my case for R2, I'm using a 10K resistor with an 0603 footprint. If I pull up the footprints tab here, we see that I have selected a hand soldered footprint. If you're getting this board manufactured, you could just use the normal 0603 1608 metric. However, in my case at the time, I put this board together by hand. So that's the difference between the two. It's just going to be slightly larger pads so that you could fit a soldering iron. So we'll go to Digikey and we're going to search 10K 0603. Hit enter. Now we're going to select the chip resistor surface mount as our result. From here you will see a list of different filters. The first thing you want to do is go under stocking options, hit in stock and normally stocking. This will reduce the amount of search results. From there, we want to select the actual resistance. So in this case, it's 10K. Our tolerance we'll select at 1%. Depending on the application, you may need a lower tolerance, but considering this is just a basic buck converter, 1% is fine. Same thing goes for the power dissipation. You could calculate the amount of power dissipation across your resistor with V times I, or I squared R. This is dependent on the voltage and current that you have in your system at that given point. From here, we don't need to worry about the operating temperature, but we just want to select that it's an 0603 1608 metric package. From there, we can hit apply all. And now we'll see a list of all the different resistors that we can choose. So under the price column, there'll be this little up arrow. Click on that. And then what it will do, essentially, it will list the resistors from the cheapest price to most expensive. We want to select a resistor with a minimum order quantity of 1, as this is just for small scale engineering and not for production. If we need more resistors, then we would buy something like this where the minimum quantity is 5,000. In this case, I'm going to go with this part here. And under the customer reference, we should actually set the reference designator that we set in our schematic, which in this case is R2. Now, usually when I order resistors from Digikey, what I'll do is I will order double the quantity of what I'm actually using. So if I'm only ordering 1 resistor, I'll order 2. If I'm ordering 2, then I'll order 4. Or if I need to, rather, then I'll order 4. So this is just in case if you lose a resistor or one of the parts you insert in the wrong way. It doesn't matter with resistors, but say for instance like an electrolytic capacitor, you always want to have extra quantity if you want to make more boards. So this is really only useful if certain parts that you're ordering through Digikey or Mouser aren't available through LCSC with JLCPCB. Their search engine isn't the best, and sometimes they may not have the part that you actually need. Alright, so once you fill in the information for your normal resistors, we're now going to be looking for a potentiometer. So we know that we want to use a 50K pot, and for this board I made it surface mount. So what we'll do is we'll go back to Digikey, we'll search 50K pot, SMD. From there we're going to select trimmer potentiometers. And then once again, these stocking options are going to be in stock, normally stocking, resistance 50K. The power wattage that I chose was 0.5 watts. Not really needed for a feedback pin, as I said earlier. Not a lot of current's going to be flowing through it, but this is what I selected at the time. And then we're going to hit apply all. So now we have 3 possible choices. we'll go with the lowest priced component, and from there we can enter in our information. So this is the part number that we're going to select. E for edit. Put that here. We'll grab the Digikey link, and we'll put down the price. So in this case, it was $1.39. Description, we'll just copy straight from Digikey, along with the data sheet. So we'll just open that in a new tab and copy and paste the link. And essentially, you just want to repeat the process for that for the rest of the components. I'll show you how to get a capacitor and select an inductor, as there are certain properties that you want to pay attention to. But for the most part, it's a very straightforward process. You simply just filter in which what you need. If there are more parameters that you need, you could go through those as well. The more specific your search gets, the less search results there are. Again, very straightforward, very easy to do. So now we're going to order the capacitors. What you want to try and do when establishing a bill of materials is limit the amount of parts as much as you possibly can. So in this case, I have 3 components, all of which are 47 microfarads, C1, C3, and C4, and they're all the same package type, 0805. I'm doing this to reduce BOM cost and quantity. The better that you are with this, the less the overall cost will be for your project. Now, there will be times where you can't do this, where you have to get a different capacitor value, whether or not you're making a certain cutoff frequency or the chip that you're using is very frequency dependent. In that case, don't consolidate your BOM just for the sake of it. But if you can, again, try and reduce your parts as much as possible. So we're now going to go to Digikey, and we're going to search 47 UF 0805. I'm going to hit enter. From there, we're going to select ceramic capacitors. Now again, there are different capacitor types depending on the application. If you need something that's polarized, you would get a tantalum capacitor. Again, this is another version of the polarized capacitor, but it's polymer. In this case, we're just going to use ceramic. A lot of times you can just use ceramic, but read the data sheet, look at schematics online. If you're unsure, ask people on forums. Someone will give you an answer one way or another. From here, again, we're going to use the same stocking options in stock, normally stocked. Capacitance, 47 microfarads. Our tolerance, we would like to try and hit plus or minus 10% for most of our components. This is not always going to be the case, so sometimes you're just going to have to use plus or minus 20%. That works fine too. For the voltage rating, this depends on what voltage you're using in your circuit. What I like to do is use double the voltage of which I'm expecting at the highest possible output. So, for example, in the case of the buck converter, if it's getting 5 volts in and it's pushing 3.3 volts out, then I would want this capacitor here, C1, to be at least rated double that voltage, which in this case would be 10 volts. So always try and do that with your designs. You don't want to be at the minimum threshold. It's just a very thin line to cross, especially with capacitors, because if you exceed that voltage, they will pop, which can be dangerous depending on the size and the voltage that the capacitor is holding. So from here, we can now go to apply all. And as we can see, once again, we have several options. So for this, I'm just going to hit the price tab yet again. And we could go with something like this. Now, again, we know this is the exact part that we're looking for, as it has the tolerance, capacitance, and footprint. Make sure that your footprint matches what you select in the schematic. If it doesn't, sometimes you can get away with it. If it was an 0603, it would fit, but if it's a 1206 that you order and you have an 0805 footprint, that won't work. So you're essentially just going to want to do this for the rest of the capacitors that you have, depending on the actual capacitance itself. Sometimes on Digikey it won't show up, so you may want to convert the nanofarads to microfarads. You could just use an online converter for this, and then from there you could go through the search engine. Okay, so the last two parts we're going to be looking for are the inductor and the IC itself. We'll first start off with the inductor. So on my schematic, I have a 4.7 microhenry inductor with a 2.2 amp current rating. That's what this 2.2A says in purple. It's a custom reference, so anything that you add that wasn't originally in the symbol will come up purple. So now if we go to Digikey, we're going to look up 4.7 UH 1210 SMD, hit enter. Go to fixed inductors. And from there, we're going to do our usual search options. For the tolerance, we're going to select plus or minus 20%. Current rating we said was 2.2 amps. We're going to select shielded. Now, unshielded inductors will induce a lot more EMI. It's always best to pick a shielded inductor, as inductors are the noisiest part of a switching converter. So make sure that's selected there. Self-resonant frequency. This is the frequency in which the inductor starts behaving like a capacitor. So again, for our application, not too important, but just keep that in mind. And we could pretty much just select the 1210 package type and hit apply all. From there, we now have our component, and we could once again enter the information. We'll now go back to our schematic, and we're going to search up the IC that I have here. So we're just going to put this in the search bar, and it comes up here. It's a buck converter, as stated earlier, fairly cheap, can withstand a decent amount of current, and the only other thing that you would really need to do before you order your parts is just verify. Do the parts that you have on Digikey come up in LCSC? Now, you can use LCSC originally before making your boards, but I find that they have a very limited quantity and supply of parts. In this case, they have this part, but I'm pretty sure that the inductor that I originally selected for this project, they do not have. So sometimes what you could do too to even save some money is when you're putting a board together, some of the parts you get manufactured, the ones that you have trouble soldering on, and the ones that you know you could do confidently, keep those off the board, order them from Digikey, and put them on yourself. So once all of this is established, you can then create a bill of materials that is going to be in this little BOM section here, and you could export the file. You could also even choose the type of format that you want to use for this. Now, I'm not actually going to use this export. I'll show you what I'm going to be using later, but we'll now move on to the PCB section in which we will create the Gerbers and CPL files that we're going to need for this project. All right, so now that we've established all the components that we need for a board, we can then go in the PCB editor and set up the board configurations. So in this top left-hand corner here, I'm going to hit Board Setup. From there, we'll be in the Board Stack Up Board Editor Layers tab. We're going to go under Design Rules followed by Constraints, and we're going to fill out the PCB specifications that we have based on our manufacturer. So these you can find on the JLCPCB website under their Capabilities tab, and they'll have a list of all the different PCB specifications that they can do for manufacturing and assembly. So for example, if we scroll down to the traces section, we could see the minimum track width and spacing is at 0.1 millimeters. So on my settings, I have it at 0.2. I always set it a little bit higher than the absolute minimum threshold just for safety precautions so that we don't have any problems when they try to manufacture or assemble the board for us. So you could copy these settings if you need to. I've never had any problems with JLCPCB with this, so this is what I always try and use as a default for my projects. Same can be said for also the net classes. This is what I always set up before I actually start laying out the components and routing the board. But once this is done, we can now go under File, followed by Plot. From there, we need to select the output directory. So we're going to hit this little folder tab here, and we're going to select Buck Gerbers V2. This is the folder that I put in my project. So hit Select Folder, make the path relative. Normally when you have the plot menu open, the Generate Gerber Job File check mark is going to be selected. Unselect it, and make sure that you have all the included layers that you need for your project. From there, we're going to hit Generate Drill Files. Leave everything as default. You could change the drill units to millimeters. We're going to generate the drill file, hit Close, hit Plot, and now we have all our Gerbers. From there, we're going to go back to File, Fabrication Outputs, Component Placement. Leave everything as default. Make sure you make a folder for this. So in my case, I called it CPL Buck. Select Folder, Relative Path, yes, and generate the position file. Now what we want to do is just check the project. So we're going to go under Buck Converter, or Buck _ Gerbers V2, and I'm going to hit this top file here, hold the Shift key, go to the bottom, click on the bottom file, then I'm going to right click, go to Compress to, Zip File, And then I'm going to name the zip file buck underscore Gerbers underscore v2. Hit enter. Minimize that. And from there, we could start ordering the board. Okay, so now we're under the order section of JLCPCB. What we want to do is add the Gerber files. So we're going to go back to our project here. We're not going to select the files individually. We're going to select the zip that we made earlier. So we're going to select open. And from there, we'll see the front and the back of the board. Now, what we could do is there's a Gerber viewer in JLCPCB in which we could check all of the layers and make sure that we put every single layer that we need in order to properly manufacture and assemble this board through JLC. So here's a 2D view of our PCB. Here's a 3D view of it. And if we look at the layers, we have the silk screen, the bottom, the top, the paste, top and bottom copper layer, bottom solder mask, bottom outline, and the drill file. So we pretty much have everything that we need for this. You could also select and deselect the layers to just check that everything looks good. So we're fine with that. What we're going to do now is the surface finish. I always go lead free. It's $2 more expensive, but I don't really like the idea of having lead in my PCBs, so that's why I choose this. And the mark on PCB, we'll just put a order number. We'll specify the position. That's the JLCs that I have here on the back. And we're going to do PCB assembly, so we're just going to check this off. We're just going to get the top side assembled as there's no components on the back. I don't think JLCPCB can assemble both top and bottom, unfortunately, but in this case it doesn't matter. And everything else pretty much checks out, so we're going to hit next. Now we'll see that the PCB quantity is at 5. Economic, top side, we're going to hit next again. So the BOM and CPL files that we have, they have a sample BOM and a sample CPL file, which I have selected here. So this is the sample BOM that they have, and they also have a sample CPL file. This is what you want to use when making your files. Now, the generated CPL file that we have will not match this template, so you could just do a save as on this and put in the information that you have for each component. And that's the reason why I didn't make a bill of materials earlier, because you just want to use the JLCPCBs format for this, because if you don't, they're not going to recognize it. So I'm just going to quickly fill this in for both the BOM and the CPL, and then we could go from there. All right, so I filled out all the information for the CPL file along with the bill of materials. Now for the part number column, just make sure you fill out the LCSC part number. As I was saying earlier, LCSC is not the greatest in terms of its part selection. A lot of parts have a higher minimum quantity than you often need. If the part is an extended part as well, it will cost more money per unit, and just their filtering results often don't work. So you're going to have to use that to the best of your ability. Make sure that the part is available through LCSC and on JLCPCB, as I've noticed some parts on LCSC are available, but not through JLC, which is really strange. But once you have all that done, you could then hit next, and you can upload your bill of materials and CPL file. I have it saved as an XLSX file for both of them. Now here's the bill of materials. What you'll notice on the last column is there is a shortfall for the potentiometer. Again, this will happen often, as even with PCB or other manufacturers, they may not always have the parts that you need, which is why I recommended hand soldering when you absolutely need to. But another thing I want to mention too is the CPL file itself. You want to make sure that the rotation is set properly. So for example, when I made the original CPL file through KiCad, the rotation for U1 was set to 0 degrees. This is not correct. It needs to be set to -90. This you could kind of just play around with and re-upload the file. It is kind of annoying, but as long as you get it right and the board gets assembled properly, that's what matters the most. So here we can see I have pretty much all the parts that I need. Some of them, or most of them rather, are extended, which will also increase the cost, as this is a problem I seem to run into frequently when designing my boards. But this is just something that if you can, try and avoid it. Maybe combine capacitors in series to get the same value for a basic part, or combine resistors in parallel. It really just depends on the space and size constraints of your circuit. But from here, you're going to want to click Next, select Do Not Place for the potentiometer in this case. And now we could see the actual board itself. So we have the IC with pin 1 correctly identified, which is good. We have our inductor, the 1210 footprint, the 0805 capacitors, the 0603 capacitor, and the R2 resistor. Now V in and V out are just pads. They're meant to have wires soldered onto them. Should have used pin headers, but didn't really think of it at the time. And all you would just want to do is just verify, does everything look right? Are ICs placed in the right designation, in the right orientation as well? Does pin 1 match? If a capacitor is polarized, is the positive side facing the positive side, or is the negative side facing the negative side? Same thing with an LED. Is the anode on the anode side? Is the cathode on the cathode side? Just go through a list of all these checks that you would have for different parts, as it's very important. But then you can select Next. And from here, you could see what I'm talking about with price. So the price to actually just get the board assembled with no parts is very cheap. However, the assembly price is where it starts to get costly. And this is why I don't recommend you get boards assembled if you're only ordering quantities of 5. If you really need to get a board assembled, get the parts like a microcontroller or a QFN package or a small surface mount package that is just a pain to solder with either a soldering iron or a heat gun, and get that through JLC and then solder the rest by hand. You'll save a good $20 to $50 depending on how many parts you have on the board and how many layers there are. And you could also potentially save yourself time, because if you happen to mess up in the component placement section and put an IC in the wrong orientation where it was supposed to be, you're then going to have to remove that IC and put a new one. Now, this is again something that you should check before you order the board, but mistakes can be made, especially if you have a deadline or if you're rushing a project. So this is just something to keep in mind. All right, so once you place the order and wait several weeks, or depending on what shipping method you select, you'll then get a blue box from JLCPCB. And inside you'll get a quantity of 5 or whatever you ordered for your circuit. So essentially all the parts will be pre-assembled on there. It will look a bit cleaner than this because at the time I hand soldered this board. Here is a blank board for comparison. As you can tell, it's the bare bones version of the finished product. And then from there, you can just test your circuit and use it for whatever given application that you need. Now, one thing I will say about JLC PCB and their assembly services, I've never had any problems. They work very well, and very rarely have I ever seen people online complain about cold solder joints or solder bridges. Now, you still should check for that when you get the boards. Go through all 5, just make sure that there are no problems, because they will solve that for you if you go through their customer service portal. But other than that, you're pretty much done with your project. And one other thing that I wanted to mention, if you do plan on hand soldering your boards, this is an example of a package with the customer reference here. So as you can see here, this is a 10 kilo ohm resistor, 1% tolerance with 1/10 of a watt, 0603, that's the power rating, by the way. And for RA6, this is the reference that I selected for it. So you'll just get a little cut tape and reel of the resistors. So in this case, I ordered 2 of them. That's why I have these 2 little notches here with the resistors inside. And if that's not enough for you, if you feel like you need more parts when you're testing or troubleshooting your boards, what you could do actually is ordering a sample book. And these sample books will have common E6 values for capacitors or resistors. This book happens to be a capacitor book, so it has all common 0603 ceramic capacitors. So as you can see here, we have 5.6 picofarads. We've got like 30 picofarads. List goes on. I think it goes up to 1 microfarad, maybe slightly higher. Yeah, it goes up to 2.2 microfarads. But you get a whole reel of these. So if you're only planning on putting together one board, you could essentially buy 2 of these books and then put the circuit together. And that's another way that you could save money if, again, you're doing this as a one-off hobby project and you don't want to mass produce these. If you are going to mass produce your board, definitely get as many parts assembled by a machine as possible, as that will save the amount of overall time and cost in that case. Say, for instance, you're getting 500 boards produced. You're not going to want to put 500 boards together by hand. As always, thank you so much for watching. I really appreciate the recent support that you guys have given me for my latest video where I delved into programming STM32s and how to bootload them and the process involving in that. So I really appreciate all the recent subscribers and comments that I've been getting. It is really a big motivation to keep going on this channel. I do plan on continuing delving into embedded hardware along with a larger project that I'm planning to showcase very soon. It's still a work in progress, but I want to show you the initial steps and some of the theory that I go through and calculations, as I know people were asking for that as well. So as always, thank you all for watching and have a great day.